Hi guys, I wanted to give you a quick tutorial on how to solve a physics math problem or a chemistry math problem or any sort of math problem in science. This is kind of a down and dirty way to get this done. This may not be the fastest way, this may not be the most efficient way, it may not be the way your algebra teacher taught you how to do it, but this way we'll get it done every time. And if you do it this way and you follow these 6 steps every single time, you're going to get your problems correct with variables. So this goes for any science problems that have variables. So we're going to look at the 6 steps and then we're going to go and do a couple of practice problems. So here we go. So the 6 steps to solve it start with this. You're going to circle all the information that is important. Usually this stuff is anything that has a number. So this is 125V. That's what you're going to underline or circle. You underline the important facts and you circle what you're solving for. So if it says, what is the distance? You're going to circle distance because distance is what you're solving for, right? We circle what we're solving for. We underline any other important facts in there. That draws our attention to what's important. It helps us so we don't have to keep going back to the problem. We've already have everything out there in the open. The second is we write down the unit symbols in your unit box. So we're always going to make a unit box somewhere on our page, right? This, like I said, this method is going to get you the right answer every time. It takes a couple steps. Once you get good at it, writing all these things down is going to be really quick, but you have to do it, especially if you're struggling with this stuff. You have to go through all these steps. So for instance, V is, if we're talking about physics, V would be a volt. So V volts equals 125, right? So this is where you kind of got to know what these symbols mean. If you don't know what those symbols mean, you're going to be in trouble. So hopefully you've got something to help you find that. So once you find out what the symbols mean, it helps you out. And that distance, the symbol for distance can be either an X or a D. Let's just put a D there, lowercase d, equals what? Well, we're solving for it, so this would be a question mark, okay? So obviously your formula or your unit box would have a few more things than those two things because you can't get a formula from that, but this is a start. Then you're going to find an equation that matches this. So I'm going to find some equation that we've been going over in class or that you've been studying about, because it's usually going to be something that you've recently been studying about if you're doing it in your class, that has a V in it and that has a D in it, that has volts and distance in it, right? This volts and distance, I don't know of any equations that have those two things in it, but if there was one, I'd be able to find it and I'd be able to write that thing down. After I find the formula that does it, so let's just, for instance, I'm making this up. This is not a real equation, all right? Let's say time equals volts times distance. So this is absolutely not a formula. I'm just making up variables here. All right, so I'm going to rearrange the equation to what we're solving for. So what are we solving for here? We're solving for D, right? We're solving for D. We circle D here, we circle D here, so we're solving for D, okay? We're going to rearrange the equation for what we're solving for, and then we're going to plug in the numbers and do the math and solve it. The steps to rearrange the equation, I'll go over in the next part, right? Steps to rearrange the equation, again, this is not necessarily what your math teacher might tell you to do, but it's going to work, and it's very, very effective. Plug in the numbers after we've rearranged the equation and then do the math. In this case, what we would do, actually, let's just do it right here. Actually, I'll go on the next page. Let's try that, okay? So these are our 6 steps. Follow along here, oops, and we'll get through this. All right, so here's a sample here. If oxygen gas occupies 250 milliliters, right, that's an important fact, right? You got a symbol there, you got some numbers, it's obviously going to be important. At 730 millimeters of mercury, how many milliliters will it occupy? Uh-oh, there we go. How many milliliters, that's what we're solving for, will it occupy when the pressure is 1,460 millimeters of mercury? The temperature remains constant. Okay, so this is a problem that we recently did in my class. We're talking about the combined gas law. So immediately I know that milliliters is measuring for volume. So the combined gas law I'll talk to you about, this is going to be V1 equals 250. Again, and I know that I know that it's V1 because we're talking about the combined gas law because that's what we're doing in class right now. At 730 millimeters of mercury. Well, we talked about that. That's pressure, so that's going to be P1. Again, I know this from class because this is what we've talked about in class. How many milliliters will it occupy? So my V2 is going to be a question mark, right? I don't know. How many? I don't know what that is, right? This is how you find out what you're solving for, right? I circle it up here, circle it down here. Well, okay, when the pressure is 1,460 millimeters of mercury. So P2 is going to be 1,460. The formula for the combined gas law, right, is P1V1 over T1 equals P2V2 over T2. All right, now combined gas law, we know that temperature remains constant. If one of them is constant or doesn't mention it in the problem, we can get rid of it. So let's get rid of temperature here. Let's get rid of that temperature here, and we're left with P1 V1 equals P2 V2. Do we have all three of those variables here? Yes. I have a V1, I have a P1, I have a V2, and a P2. So I've got my formula. If I look back at this, I am right here, find the equation. Then I'm going to rearrange the equation to what we're solving for, okay? So once again, we had P1 equals 200, I'm sorry, V1 equals 250 milliliters. P1 equals 730 millimeters of mercury. V2 is our question mark, and P2 is 1460. We also know that millimeters of mercury can be converted into ATMs, atmospheric pressure. Right, this is just another aside. And so 760 millimeters of mercury equals 1 ATM. So I got to convert that to this. So I just divide 730 divided by 760, and I'm going to get 0.92. So P1 becomes 0.92 ATM. Okay, again, I got that information. P2, 1460, is going to equal 1.92. Oh, actually, this equals 0.96. Sorry, 0.96. 1.92 ATM. I did 1460 divided by 760. Quick way to remember this. If this number is bigger than 760, you know that your ATMs are going to be bigger than 1, right? This is more than 1. 760 is one of them, right? So if this number is more than 760, your answer is going to be more than 1. So if you forget which way to divide it, you can look at that and use common sense. 730 is less than 760, so it's less than 1, because 760 is 1. 730 is less than that. It's going to be less than 1. So you'll know that 0.96 is less than 1, so you know that you've done it correctly. All right? Then we just do our formula. We had P1 V1 equals P2 V2. All right, so my P1 is 0.96 ATM. My V2, or my V1, is, I'm going to write this right underneath of it since I'm running out of room here, 250 milliliters equals, my P2 is 1.92 ATM times my V2. All right, real quick, we do the math. Well, first of all, I got to solve for V2, right? Solving for V2. So I got to get V2 by itself. And so how we do that is we put up a fence, we put up a cross, and we get V2 by itself. Well, you can move V2, you can move any variable anytime you want, as long as you move it 2 times, right? So it's on the, you got to move it to the opposite each time. You got to move it by 1. So it's on the right, so we move to the left. It's on the bottom, so we move it to the top. So we rewrite this as we're going to have V2 times 0.96 ATM over 250 milliliters equals 1.92 ATM. All right, put my fence up, put my cross up. Every time I move a variable, I rewrite it. I'm still solving for V2. Ask myself the two questions. Is it on top, and is it by itself? Watch the other video if you need more practice with what I'm doing here with the fence and the cross and whatnot. How to rearrange equations, it's called. Is it on top? Yes, we got it on top, right? That was the first thing we did. Is it by itself on its side of the fence? Well, here's the fence. Is there anything on this side, on the left side of the fence? Yes, there's two things. So we got to get rid of the 0.96 and the 250. So I can move 0.96 two times. It's on the top, so I move to the bottom. It's on the left, so I move to the right. So 0.96 ends up over here. Cross that out. Let's use a different color for this. I got 250 here. 0.96, so you know that I moved it. Got 250 here. It's on the left, so I move it to the right. It's on the bottom, so I move it to the top. And you got 250 milliliters up here. Sorry, I'm running out of room. Cross this one out. So now rewrite the whole equation again. V2 equals 250 milliliters times 1.92 ATM divided by 0.96 ATM multiply 250 times 1.92 and divide by 96, and V2 equals 125. And what we measured in, we're doing volume, so it's going to be milliliters. All right, and there's my answer. All right, so that's the steps that I took to solve this. We'll do some more practice in another video. This one's getting a little bit long, but that's it.